Okay, and I need to. Okay. If I want to point to something. Okay. No, no, there is a video, but there's no sound there. So that way it's okay. And I have to stand here for the video or okay. So the video is here. Okay, okay, okay. So I just need to be there. All right. Good to go. All right. Good evening once again. Thank you so much for this opportunity. We are so happy to be associated with the Institute of Structural Engineers. So today's discussion, the topic is going to be on how do you design a protective coating system from a durability perspective? What do you talk when you talk about life of a structure? You say, I built it for 50 years. What about the coating system for that? And when I talk about coating system, we are also talking about protection against corrosion and fire. Right? So what we're going to do is basically understand who Hempel is, first of all. And I'll also introduce a few standards like ISO12944, which is very commonly used. And we will also talk about EN16623. Are these standards, where can be applied? I'm a civil engineer primarily, uh, but I'm into this field of coatings and linings for about 28, 30 years. I've been in the Middle East for about 25 years now, a little more than what was the time spent back home in India. Uh, my area of specialty is actually looking at durability of intumescent coatings. A lot of times we do fire protection, but are these coatings designed for fire protection also able to protect your structure against corrosion? A lot of times when we design a coating system, we tend to forget that when you aim for one particular result, you may compromise on something else, right? So how do you balance that? Where do we bring that? In fact, we had we were just before the presentation we were having a chat, right? And they were asking, this environment is C5, and how do I provide a coating system which will provide corrosion and fire? Remember, statistically, I was just telling him, the structure might not see fire. We need to protect it against fire, but statistically, it might not see fire. But 100% of all structures will see corrosion. So how do you ensure that we protect? So we will get into those areas, and that is one of the areas where we talk. So before I get into the presentation, I'd like to talk about Hempel Paints. The company was started in 1915 by this gentleman. His name was J.C. Hempel, but he or his family does not own the business anymore. He set up something called as a Hempel Foundation. The Hempel Foundation is the owner of Hempel. So the work that they do is a lot into the protection of biodiversity and saving people, especially from the poverty. So the way we go about poverty reduction is by making sure that the learning poverty is removed, right? So this is our focus area, right? We empower children to try and learn, because we believe that if you are able to teach them to learn, then they will come out, they will break that poverty cycle, right? Recently, I was in Rwanda to see the actual work that Hempel Foundation does, right? We also do protect a lot of the forest, right? So our aim is to protect about 5 million hectares of tropical forest by 2030. That's what we want to do. And we are looking at trying to help children, because what we see is in poor countries, 9 out of 10 kids who come out of school do not can't read, right? So this is me dressed like an Arab, right? Because I was representing the Middle East, where I was teaching geography, right? To those kids. And those kids are in something called as a remedial class. They are not able to pass to the next class. So Hempel Foundation is providing money for the teachers to try and do that. So our ambition is to reach about 1 million children by 2030. That's why we're doing. So Hempel, so when you work with Hempel, right? CSR is not another part of what we do. It's part of everyday work. So when I go in and when I'm working hard, I know that the work I do is helping a child in a different part of the world. It's a direct impact. So Hempel is owned by Hempel Foundation. So this is what I wanted to share. And now I will get into the main area of discussion that we have, which is corrosion protection. Right? So we are all engineers here. We work with steel. And one of the issues we have with steel, a great material, is that it starts to corrode, especially in an area here where it is fairly corrosive, right? So you need, it's an electrochemical process. So the steel in the presence of moisture, in oxygen, and there are electrolytes, salts, then this accelerates. One of the methodologies is to isolate the steel from the environment, right, with a coating. The protective coating system is one of the methodologies, right? There are only 3 methods in this world to protect any structure, any steel member from corrosion. There are only 3 methodologies available. One is what we just saw, right? You put a barrier. You isolate the steel member from the environment. We call that the barrier system. The other system is to say that, hey, this is an electrochemical process. Okay. So you have these things. Can I remove oxygen? Can I remove the moisture? Right? Can I remove one of the things so that this does not happen? For example, when ladies go and buy your handbag, right? Your slippers, there's one small packet which says do not swallow, throw it away. That is basically silica gel. What it does, it absorbs moisture to make sure that the leather doesn't get damaged. So that is an inhibition process. Similarly, if I'm able to remove one of the reactants, then the product, which is the corrosion of steel, is stopped. That is a methodology that can be used. The very common methodology is people saying, I want to do galvanizing. I want to apply a layer of zinc. What it does, it corrodes and protects the steel underneath. Right? These are the 3 methodologies. But every methodology has its own advantages and it has certain disadvantages. Right? The barrier protection is fantastic theoretically, unless you have one small hole somewhere and then corrosion starts and creeps underneath. Inhibition is used extensively in the process industry. For example, when you have a piping, right, you have liquid going in, we try to provide oxygen scavengers. So they will remove all that. So you add small quantity of corrosion inhibitors that will make sure that the internal pipe remains clean. In a coating system, yes, we can use it. But even more effective than that is to have something like a layer of zinc. So what will happen is, in case the barrier gets a holiday, if you combine the barrier effect and the galvanic effect, right, then you get a duplex system. So if the barrier gets damaged or there is a small hole, then the corrosive elements can go in and affect the steel. Then you have this layer of zinc that is protecting it. So generally, in a corrosive environment, you would specify a duplex system. On a steel, you will provide a zinc-rich coating, and above that, you will provide a barrier to ensure that you get long-term durability. We are talking about durability today, right? There are certain corrosion standards available. right? We know that offshore structure is the major corrosive area. The standard that we often use is called NORSOC M501. This is a Norwegian standard, especially used in the oil and gas industry. Very, very commonly used. The other standard called ISO 20340 has been replaced now by ISO 12944-9. Yeah, this is part 9. When you look at the onshore structure, you generally go with ISO 12944, and I will share with you more details on how this document works, right? So now, this is an extract from ISO 12944, part 2, table 1. The whole world, from a corrosion perspective, is divided into 6 categories. It starts from C1, it goes up to C5, and then CX. CX is primarily offshore, right? So from C1 to C5, this is onshore. Now the question is, I am building something on Palm Jumeirah. I'm building something in Alain. What is the environment? Oh, it is coastal. Therefore, it should be C5. But if you read the standard, C3 is also coastal, C4 is also coastal, C5 is also coastal. Now, what we also need to understand, this is a global standard, right? The sea or the coastal area here, and if you compare it with the coastal area in, say, India, in the Philippines, in the UK, they are vastly different. So you cannot simply say that just because my area is near the sea, it's going to change. Milan has raised a hand. So maybe if you have a question, is that how it goes? All right. Okay. So we'll take questions at the end. Great. Okay. So what is important is to understand the corrosivity here. All right. So what do we do? What does the standard say? If we want to understand, what does the standard say? The standard says that if you take a piece of metal and you leave it outside for 1 year, you come back, you measure the metal loss due to corrosion in those 365 days. That is how you will define. For example, if I take a 1 mm steel, I leave it outside and come back after 365 days, there is only half a mm. That means 500 microns of metal is lost due to corrosion. Then it is in a CX environment. So the definition is, if you have 200 to 700 microns metal loss in a year, it is CX. If you have 80, right, to 200 microns metal loss, it is C5. If there is 50 to 80 microns metal loss, it is C4. And then it goes down, yeah, 25 to 50, right, 1 or 2 mm to 25 is C2, right? Now the problem, I do not know the metal loss that is happening in my area of construction, right? We are all in the field, right? So, and there is a project specification which says it is C5 or C4. So let's delve in and see what does it really mean, right? So it basically means that C1 has very, very low corrosivity, but CX is extreme corrosivity, right? That's basically how. So the whole world, right, is divided, and we can design structures based on that, right? We also have, because remember, ISO 12944 has its limitations. A steel member which is less than 3 mm is not covered in the standard. So you cannot say I have my Z purlin which is 1.2 mm and I want protection as per ISO 12944. No, there is a limitation. This standard does not work. This standard will not talk about internal tank linings. This standard only talks about atmospheric corrosion. The atmosphere could be external, uh, exposure to the actual air environment. It could be submerged. It could be under the soil. It could be under water. It could be in the seawater. It could be under fresh water. Right? So we have IM1, IM2, IM3, and IM4. right? So the standard covers that as well, but it's only for external steel that we need to do. Now, when we talk about durability, right? So that is one of the questions that people ask. How will your coating systems work? Or when the specification says life to first maintenance, what we need to remember is there are four categories here: low, medium, high, and very high. The very high has come into the new standard, which is not new now anymore. It was released in 2018, right? Prior to that, we had only three levels: low, medium, and high. What we basically say is, if you are constructing something and if you're looking for a durability of up to 7 years, you can provide a coating system for low durability. No, I want, really, a high durable system. You have very high, which is greater than 25 years. Now, ISO 12944 is a performance standard. So you need to test the product. You need to test the coating system and prove, because we don't have, the time period for us to check whether the coating will work or will not work. So we need a system which will say that it works. And another thing we need to remember is that durability is not the same as guarantee or warranty. And this extract is from the standard. Yeah, I have not added any words here. Durability is what engineers can design. Warranty or guarantee is a document written by a lawyer to make sure you cannot get $1, 1 dirham, 1 riyal out of that, right? A lot of times I find many consultants who are very happy with warranty documents. Little do they know that that document is not really providing anything. And what I also find is many consultants who say, hey, I've got this letter from this manufacturer. He says this system works. But what are they saying? And what is the standard saying? How do we do that? So one of the roles, the primary roles that I've been, working on is to try and share knowledge about these standards and what these standards say, so that you can make a judgment, an engineering judgment based on that knowledge, right? So what does durability really mean? Durability means that is a time frame with which you can design a maintenance program on your structure. Because remember, if you buy a car which says that, oh, it's 5 years warranty, that doesn't mean that you will not change oil, or you will not repair, change the tires if it gets repaired, right? You need to maintain it. Similarly, a coating system also needs to be maintained. You have to inspect it visually at least once a year, touch it up, because when you install the structure, install the building, you will find that somebody goes later on to do some work, part of the maintenance, part of some other work. So what happens is that the coating system tends to get damaged. Suddenly there is a new pipe installed, somebody drills a hole, right? They will always say, do not paint over it, and he's painting. Do not walk over it, and everybody is walking over it, right? So we need to ensure that there is something. And durability basically means that if I'm saying I'm going to have a major maintenance in 10 years or 15 years time, then you choose high. I want to postpone the major maintenance for a very, very long time, then you choose very high durability, right? So this is how it is that works. All right. So this is basically the system that we have in the standard. Okay. So if you want to protect a coating system for very high durability, which is the last column. So this table is from the ISO 12944. This is for C5 environment, which means that if I leave a piece of metal, there will be 80 to 200 microns of metal loss in a year. I will also share with you how we can analyze that. So as a consultant, if you say, hey, I don't know, or I don't want to take a very conservative approach, or I want to, really understand what it is, then we can help you to measure the actual corrosion loss in the location. Because remember, In the Middle East, we say, oh, it's a very, very corrosive environment. Yes. But if you see the reason for the corrosion, okay, there are four things which contribute, four factors: the temperature, the humidity, chloride deposit, sulfate deposit. These are the four things which can contribute for a steel, right? Temperature is high. Yes. Humidity is high. Yes. But remember, it's annual temperature, annual humidity. So you don't just take July, August, where, we have the highest humidity, right? Then the chloride and sulfate. Sulfates primarily come from diesel. The diesel that we get here is low sulfur or sulfur free, right? And the emissions from the industries are also contributing. And here there are very, very strict norms. Chloride, which is a major contributor, here we don't use de-icing salts, right, on the road. So there is no salt on the road coming in, but it will only come from the sea. Now, if salt has to come from the sea, then what has to happen is the wind has to pick up the water spray and it has to come inland. Water vapor is purely water, right? So evaporation is not the issue here. You need the water spray to come. Now, if that water spray has to come, that means you need strong winds. Yes, we have strong winds. You also need a high wave. You don't have high waves here. We are living in the Gulf area. We don't have high waves. Most of the wind that we get are from the land to the sea, right? We have Shamal winds, right? Which is Shamal is north. Yeah. Primarily, I'm not saying there is never ever wind coming in. Primarily, the wind blows from the land to the sea. So to really understand any structure which is closer to the area near the sea, near the marine coast, exposed, is C4. You don't have to go to C5. It is actually C4. We are spending a lot of money. We are putting in a lot of efforts. It is only in a C4 environment. And there are studies done. There are papers that I've written, which I can share with you to basically understand. There are websites which I will share, which you can go and you can measure what is the corrosivity of that particular location. If you provide the location details, the documents will provide, right? All right. So what we need to do now is, if we say, no, my structure is C5, then you have to provide a very high durability. Then we should be giving a coating system for 320 microns. It will contain a zinc-rich primer and a epoxy and polyurethane top coat. Okay. So the total coating thickness should be 320 microns. So you can design. So when you write your specification or when you have a project, you're checking that you need to make sure that you have a coating system which meets the standard. But it doesn't say that, it just meets the standard. You should also ask for third-party test results, right? So if you go with a system like this, right? So you've got a primer, you got a mid coat, and you got a polyurethane top coat. Simple general specification that you have provided. But what is important is to understand that whether they have tested it, right? So if you look at this is a third-party test report. I've just taken a few experts there. So you can see that this is a system, right? So they've given a primer, which is called Avantgarde 750. I will explain what this is, right? It's 40 microns. So this is a zinc-rich. It's an activated zinc-rich primer. You've got a mid coat, which is an epoxy mid coat, which is the barrier. And then you got a polyurethane top coat, 60 microns. So we have built it to 320 microns. And then we have done the testing. If I pull this down a little, yeah. So you can see that we have tested it to ISO 12944 part 6, corrosivity category C5. The durability range is very high, which means greater than 25 years. That is the durability that we have tested this for. And the summary of this test report says that this sample with this coating system has passed C5 very high. So you will have to ask that you have a proven system. So now you are not experimenting. Here already there is a test that is done, and that test clearly tells you that the coating system you have selected meets the requirement. All right. So this is very important. Now we will try and understand what this zinc coating does and how do we improve that, because one of the things we have is sustainability is a major issue, right? Every project we talk about sustainability, right? Lead, correct? What we need to understand is lead, they talk about internal indoor environment primarily. That is what they primarily talk about. Living area, what is the VOC coming out? And the lead document, when it comes to VOC, which is volatile organic content, right? Which is a major consideration. They only talk about if the coating is applied at the site, right? So you have your wall coatings. You want to ensure that within the living quarters, it is clear. But what is also important is, I was hearing that, you're doing a study on the embedded carbon in your steel structure. Steel generally has a lot of recycling which happens, and their embedded carbon is very low, right? But what is also important is to understand what is the embedded carbon in your coating system. It's not just the VOC, right? If I'm spending a lot of energy and spending a lot of fuel to bring it from somewhere else, if it is not locally manufactured, a lot of times we find specifications with products listed which is not available here, right? So then you have to go and say, sir, these products are not available here. They say, oh, you get a letter from the manufacturer, right? So sustainability is not just trying to measure VOC. It is not just trying to measure, what is the carbon footprint of that. You need to look at it holistically. We talk about cradle to gate. We talk about cradle to cradle. What about the can of paint that is there? Can we recycle that, right? So there are a lot of things. Similarly, when you come here, what you need to look at is, can I reduce the zinc use? Because the zinc, if you see, it is mined in open cast mines mostly. It leads to a lot of deforestation. You say, I want to use hot dip galvanizing. The process of hot dip galvanizing is very, very energy intensive, right? You need hot molten zinc into which you will dunk your steel and take it out, right? And this zinc is mined somewhere in Africa, and then you're shipping the ingots here, right? You're melting them and making them. So it's a very, very energy intensive process. So how do you then minimize our impact on this earth, right? So it's very, very important, right? So we look at it. So one of the things that we have done is, can we give the same level of corrosion protection but still reduce the amount of zinc that is used? So here, if you see, the zinc is only 40 microns. So how can we improve that, right? So that is what I want to just share with you here very shortly. In 2007, there was a paper written by NACE. NACE is National Association of Corrosion Engineers. It's one of the premium institutes that, as a corrosion engineer, we work with. I'm a certified protective coating specialist from this company, this organization, right? So what we found was only 20 to 30 microns of the zinc is being used. The other zinc is going for a waste. It is not utilized because the zinc is usually carried in an epoxy coating, and the epoxy insulates the zinc, because the zinc, remember, corrosion is an electrochemical process. You need the zinc to be active, electrically active, so that it will take in, it takes the chloride, it takes the carbonates, it takes, all the materials, and it sacrifices itself and protects the steel. Since the zinc gets coated and insulated, it's not very active. So you need to understand that we need to have a activated zinc system. So Hempel, with about 10 years of research, they have come in with a activated zinc system, which basically what it does is it removes or it minimizes the insulation. It ensures that the zinc is electrically active. It is a Zn++, okay? So what this does is to make sure that you are able to protect the coating, the steel structure much more efficiently. It also contains glass spheres. I will show you how it works. So what basically happens, I think it's hanging. Technology. Declan, I'm trying to do something by the time they come. Okay. It's working, Declan. I think it's working. You just have to do something. All right. All right. Okay. So you're comparing the conventional zinc with the activated zinc here, right? So what you will see here is that the zinc is much more active. All the green color that you see at the top is where the zinc is very active, right? And these white spots, okay, where my cursor is and where my pointer is where the zinc, that is the metallic zinc. And the darker gray areas is where the zinc is anodized or it is reactive, right? And you can see that it is much more active in this area where there is activated zinc system. And you can also see these are the glass spheres. So this is the scanning electron microscope section that you can see, where you can see how the primer, this is the actually primer, and this is the steel. Okay, so at the bottom you have the steel, and here you have the glass spheres, yeah, and then you have the glass spheres here as well. Okay, so what basically happens is when you use a zinc rich, an activated zinc rich coating system, it makes sure that there is more zinc reacting with the corrosive elements that come in, right? We also talked about corrosion inhibition, right? So if you see this animation, you will see that the water and sodium chloride is slowly coming into the coating system. And what we are basically doing is that the chloride inhibitor, it captures the chlorine and it forms a oxychloride around the glass sphere. It thereby provides corrosion inhibition. And what you can also see is that using the glass sphere, see, normally what happens when there is a coating failure, the coating, there is a small crack, a micro crack. You can see that there is a micro crack developing here, and that micro crack it gets stopped at this glass bubble, right? And on the sides you can see the corrosion products, right? So this is my cursor. Yeah, I was searching for it. You can see that this is the micro crack, and here again you can see that this is another crack where the corrosive products in green color are basically healing the coating. And you can see that the active zinc has formed corrosive products which are insoluble to make sure that the coating does not deteriorate very quickly. This is what I talked about. There is a small hole, there is a damage in the barrier coating, and then there is creep underneath. Right? So this is how it is self-healing. So when we do this coating system, what you basically get is enhanced corrosion protection. So this is on the left side, you have the uh, activated zinc system, and here on the right side you have the conventional zinc system, and you can see how the activated system is protecting it. Both have been put in the same testing, in the same salt spray test chamber for 1,000 hours, right? And this is normally what we do is we do a scribe. We cut the coating to measure what is the creep underneath, and you can see that the coating system with an activated zinc rich primer works well, right? So now what we also need to look at, we need to look at the combination, right? So now we talked about protective coating system. It's fairly simple. You have a primer, you have a mid coat and a top coat, right? It's fairly simple. The tables are there. ISO12944, 320 microns is required. Done. Now what we need to understand is you have designed a protective coating system for fire protection. Is ISO 12944 adequate? Remember, the structure that is protected against fire should protect against fire maybe in 10 years or 15 years down the line when it has been installed, right? But for the initial 10 years, it has to protect against corrosion. So how do you ensure that the coating system that you have designed provides corrosion protection and long-term protection against fire? How do you make sure that the structure does not collapse, right? This is a short video. This was a video that I shot in one of the GCC countries where a wrong coating was specified because they were not sure about the environment or somebody gave them a wrong information. Now, to repair this, it's becoming very, very costly. And more than that, you're making sure that your coating system should work, right? Because here, when you talk about fire protection, it is not about just, some area where there is corrosion, I have to touch it up. It doesn't look nice, it looks ugly. The fire protection coating that you are specifying is about saving people's life. So if there is a failure, that the coating system is not protecting against corrosion in the first place, obviously it is not going to protect against fire. So what is very important, in fact, I have a YouTube channel, I will share the link, where these videos are available. You can have a look at it to see, I share a lot more. There is another video of a coating which has failed because somebody said, oh, this is C3 internal, C2. That is why I started first to tell you what is the environment, what is C3, what is C4. Because by the time you realize this, the cost of repair is very, very costly. And God forbid if there is an accident. Now the problem is, we know ISO 12944 doesn't work in the case of a fire protection intumescent coating system. The standard, there is a standard which we can use to evaluate the durability of intumescent coatings or fire protected coatings. It's called EN16623. Because in Europe, it rains, right? Today we had rain maybe after so many months, yeah. But it rains almost every day in the UK, yeah. So, right. So what happens? Which coating system should you use? This standard defines the corrosivity category in not C1, C2, C3, C4. If they had done that, it would have been easy, right? But we engineers like complex things, right? We like to do differentiation and integration. And if they had used C1, C2, and these are again, standards, that are used, right? So now the problem is our document comes, our specification document in the project, it reads C1, C2, C3, C4, ISO 12944. Nobody talks about EN16623. Nobody knows that. It is not even one of the standards that is referred in many of the standard construction documents. So I have here a construction document which talks about C4, but how do I select my coating system, my intumescent coating system? And comparing two different standards is very, very difficult. Correct? So this table, which I can share with you in its full content, is by the British Coating Federation, which is an industry body. What they say is a coating system tested to X category can only be used for externally exposed steel. Whether it is near Alain or, near Jubail, right, in Saudi Arabia, or, in Palm Jumeirah, if there is any steel which is exposed outside, it has to be tested and approved to X category, the complete system. Because if you have a system that is approved only to Y category, it can be used only internally. It's very, very clear. So when you select a coating system and when you write a specification, you need to make sure that if your steel is even semi-exposed, right? A lot of times the steel here is at the roof level, right? You might have maybe a restaurant area out, in the roof, right? And these are sometimes cladded, semi-cladded, semi-exposed. We need to ensure that a system is correctly designed. So this helps you to understand or even specify in your document. You will say that, hey, my structure should have protective coating, fire protective coating, and it should have this standard specified. And Reem, who's here, we do a lot of work. We work with, many of the consultants and architects. We share specifications and we help them. Right. A few examples. This is King Salman Marine Complex. This will be the biggest ship repair area in the whole world. It will be bigger than even the Dubai dry docks. This is almost complete construction. It's about 100 kilometers from Jubail in the eastern part of Saudi Arabia. Now, the issue is that, they had these structures. And for example, if you see this shed has structural steel internally, right? So there is steel supporting it. Now, what is the environment inside? Is it C4? Is it C3? Is it C5? Because somebody said, oh, this is near the sea, so, it should be C5. Look at this. This is a typical issue. This was in, I can say, the Duqm refinery. Okay. So Duqm refinery is built out into the sea, and the specification said we want CX, top of the line, right? This is what the end user said, you have to provide CX. But what we need to, then we said that this steel structure, okay, which is actually the building, a picture from the site, okay, is about 2 kilometers from the shoreline. Then we said it's going to be covered, it's a warehouse structure. There's a ventilator, it's a ventilated structure, everything is fine. Therefore, you can say it is C4, sir. No, not to worry. The operation guy comes in and he says, the door will be open during the plant operation. Therefore, I expect the wind to come in, the dusty, things can come in, right? Salt can come in. Therefore, we want, if not C5, CX, at least C5. Then we told him, even if it is ventilated, because remember, unventilated building, from a corrosion perspective, an unventilated building is worse than a ventilated building from a corrosion perspective, right? So we told them, even if it is open during the plant operation, it should not be a problem, it is C4. They said, prove it. Now, what do? I take a piece of metal, leave it, come after 365 days. By the time the project will be completed, right? To help this customer and the end user, we said, okay, we will follow ISO12944. This standard allows you to do the calculation. You can theoretically calculate the metal loss due to corrosion in a year based on the parameters, which I said earlier: temperature, relative humidity, chloride deposition, sulfate deposition. So every project, okay, so this is in Duqm, you can just find out what is the annual temperature of Duqm. You can find out what is the annual humidity in Duqm, right? Very simple. Every project, before they start, they have EIA, environmental impact assessment. You will have air monitoring stations to check what is the sulfur content. So from that, you can get the reading for sulfur as well, sulfate as well. The only problem is calculating chloride, because chloride is not a pollutant. So nobody measures that, right? So now how do we identify and what do we do? So we went through, I almost did my master's thesis in this project. So, right. So we went in, did a lot of literature review. Then we found out King Saud University in Saudi Arabia, they had kept many plates, right, in different locations, and they measured what is the salt deposition. And we got the data from there. We also correlated it with other tests. For example, there were tests done where they are measuring the wave height to the distance salt moves inland. So based on that, we also say that wave height is very low, because you can check the wave heights also, the data. And then we provided, and then we calculated it. And when we calculated it, it came to 49 microns metal loss per year. 49 microns actually relates to C3 as per the ISO12944. Then we said, sir, as per our engineering judgment, this internal steel, even though we considered it as external steel, is in a C4 environment only. These kind of analysis and testing can be done for every project, right? Obviously, you will not do for every project, but at least projects where you feel that, we are either gone totally overboard, or, we are being very, very conservative. Let us understand this, right? So it is very, very important that we understand the microclimate that the steel is exposed to when you design your coating system. So what we then told them is that now, because this is only in a C4 environment at the max, please select a coating system which is tested to X category as per EN16623. It's very, very important that, we share that information. Right. So when you specify a coating system, we know it is C3 interior or C2 interior, C3 interior, right? Here, you can use a water-based intumescent, right? So you can use a water-based intumescent, such as your Optima 500, right? And what we say is that, so you have the steel, you have the primer, you have the intumescent, and then you have a polyurethane top coat. But if your steel is within an air-conditioned environment, 24/7, humidity is controlled, temperature is controlled, right? There is no ingress of salt. It is only in a C1 environment. You could leave it without a top coat. Or you say, I don't like the white color, because intumescent coatings, which are fire protective coatings, generally come in white color only. You can very well apply a acrylic top coat, which is not very costly. But these systems have to be approved, right? So that is how we can come in and say every coating system can be protected adequately for the environment that it is exposed to. But you cannot expose this water-based to even a semi-exposed condition. You should not. Right? So what basically happens is that if you want to use it in an external environment, then we would recommend that you go with a primer. I talked to you about how an activated zinc primer works. You would use a solvent-based intumescent coating, but we also need to ensure that it is tested and approved for X category. I think that's very, very critical, and that's very important that we do that, right? So what we can do is we can take more questions. I have tried to be as specific to the topics that I've chosen. So I thought I'll have some more time. So if there is any questions, then I'll be glad to take. Post the questions in the Q&A. Okay. Maybe when he's doing, if there is any question here, then we can also. Yes, sir.
Very interesting presentation, informative, an area we normally don't delve into because it's about moments of sheer confidence.
Correct. Yeah.
Something that we normally do, but we do something. Just you mentioned something that coating which was separate.
The video, yeah.
Said it was the wrong coating. It reminds me about a British Rail comment that they had derailment of the trains, and they said it was the wrong chunk of leads on the rails causing derailment. So what is wrong type of coating?
Okay.
Explain.
Yeah. So I think that's important, right? They had used a water-based intumescent in that particular steel member. They had used a water-based intumescent, thinking that it is purely internal. It was not purely internal because it was in a semi-exposed environment. It was, I will tell you, it was in a hangar, right? Aircraft hangar. Aircraft hangar will never be fully closed, right? You still, even when they close it, you will have the opening there for the tail to come in, right? So what happened was, this was about 2 kilometers from the shoreline, and they thought that it is enclosed, and therefore they said, oh, water-based intumescent will work. It doesn't work. You need that should be considered as a semi-exposed environment. So that coating system was not suitable for that environment, the microclimate that the steel was exposed to. Because of which I said that was a wrong choice of the coating. They should have chosen a coating which will withstand the corrosivity in that area. I think there is this combination which happens, right? Number one, the specification should state that the steel, if it is internal, you can go with a water-based intumescent. If it is external, you should go with that. And we should also refer to those standards, right? Number one, the specification.
Sorry,
yeah.
Shouldn't we have changed it rather than specify type of features, right? We specify the environment.
Correct.
Because I don't have to say water-based or that. We have to say it's for internal use or it's for external use. That avoids the mistake.
True, very true. So we have to make sure that the steel. Now the problem is when you interpret it. For example, in one of the projects where there was a roofing sheet on top. Okay, this was again another airport project, and then they said, oh, this is internal steel. I said, yes, you have a roof on top, but it is not internal because the covering is not there. So it is semi-exposed. So this is where it happened, because what happens at the site level, the steel fabricator, the contractor is driven by the commercial aspects, and he will come in and say, this is good for internal, or somebody might say this. So that is where I think, as probably from that is why I said it should be multi-pronged. You have a strong specification, you follow the specification very clearly, and the approval process. Here, I think what happened was, in the approval process, somebody gave this, nobody really understood what they were approving or what was the issue. And then, bang, in a year's time, it starts to crack up. And now they are finding whose mistake, how did it happen, right? So that is where we need to be very, very careful. Yeah. Correct. Correct. Yes, we do a lot of work on what is the carbon footprint of our coating system, and there we do a lot of life cycle measurements. Right? We talk about what is the longevity of the coating system. For example, I always give this as an example. When we talk about long-term corrosion protection, we talk about long-term carbon footprint coming through. Right? You look at originally when the motor car came, the internal combustion system. Right? People in the streets of New York, they said, hey, this is a savior against pollution. Now we are saying remove all internal combustion engine. Yeah? because it is polluting. Because at that time, when the Ford Model T came, what was on the streets of New York? It was horse-drawn carriages. And the manure, okay, from the horse was flying all over, and people were struggling with pollution. It was a different pollution, right? And at the time, they said, wow, this is the solution for us. It gives a little smoke. It's okay. So a lot of times when we look at sustainability, when we look at carbon, footprint, people look at a small table, okay, that we tick off, and we look, hey, what is the VOC there? What is, the heat reflective, heat island effect, right? We measure. We don't look at the holistic picture. If somebody had looked at it at that time, probably we would not have this problem. So companies now, for example, if you look at the marine industry uses one of the worst fuels available. They use heavy fuel oil. And now, the coating systems are sold based on the amount of carbon that is emitted from that ship. So what happens is, I will sell my coating and say my coating is smooth, it's sleek, the ship will go very, very fast. Therefore, you will reduce the amount of fuel that you will use. Once you reduce the amount of fuel, you will save so much carbon. Okay? So it's not something that you will fix a machine, you will fix a monitor on the engine and say that, are you maintaining that? Is your coating system helping? Because you reduce the barnacles, it will be an anti-fouling coating. Similarly, when you ask for a coating, I have never ever seen a specification which says that your coating system should not have more than so much carbon footprint. I've never seen that, right? But we all talk about sustainability and somebody says lead, right? Now, for every coating system, we have something called as EPD, Environmental Product Declaration. And in that, we talk about what is the life cycle cost. We talk about the carbon footprint, embedded carbon. We talk about embedded water, right? Water is also a major issue. We don't talk about those things, right? So we have lot of tests. We have products which we can come and tell you that this system has this carbon footprint. And we can come in and share that with you. And we can really provide a coating system which is sustainable, looking at it from very rightly the life cycle of the coating. Because a lot of times people simply say, I want lead, and the lead says you should not have more than 30 grams or 50 grams of VOC. I said, but that coating, you might need to maintain it every 2 years.
That's
Mhm.
totally.
Definitely the long, that's what it is. But what I'm also trying to say is, as consultants, we don't get those questions, right? It's only when we look at that. So we would love to present, we would love to share with you what systems can help you reduce your carbon footprint, at the same time provide long term corrosion protection and less maintenance. Yes.
Yeah, but if we have a question from
Yeah,
board, like need calculation for Duku project. So which standard we can use?
yeah, the reference standard is ISO 9223. Okay, ISO 9223. Even if you look at ISO 12944, there will be a reference to that standard, ISO 9223. But what is important is that if you have an existing structure, it is fairly easy, right? We can come and help you. If you have an existing structure, then what you do is, you take a pre-measured metal piece, standard yes 275, carbon steel material. You can just leave it outside, and you can come and measure after 365 days to know exactly what it is.
Question: how to calculate?
No, but it says,
Measuring. Question: uh, they, there calculation. because of the distance.
What you need to have, if yes, there is a calculation, there is an equation with which you can calculate. But if it is an existing structure, that is what I think we need to look at the question very carefully. If there is an existing structure, okay, he's not talking about a new project, right? Which I answered, and I said the standard also. I meant I also mentioned it is ISO 9223, but that is a theoretical calculation that you can do. But you can also do at the same time a practical measurement, and you can calculate the metal loss from that as well. So there are two methodologies that people do, because we were recently working for one of the projects in Saudi Arabia where we offered them the theoretical. They also wanted a practical measurement where they said, can you come and place some coupons? Because almost every consultant says this is only C5. And then we told them it is C4. And because the cost between C5 and C4 is quite substantial. Mm. Yeah, I think that's an important question, because what you're doing is you have steel, then you have, right, the zinc rich primer intimate with the steel, and then you have a barrier mid coat and a polyurethane top coat. Generally, what happens is that over a period of time, if it is in a very humid environment, the moisture can slowly penetrate, right? Even if there is no pinhole, it can slowly penetrate inside. But worse than that is during maintenance, if somebody goes in and damages the coating, then that means what is going to happen? There is a holiday, right? So easily moisture, salts can enter, and it can start to creep underneath the coating and delaminate the coating. So in that condition, the zinc rich primer that is applied can make sure that the creep is minimized. So creep underneath the coating is a major problem. That is why you will find all, after rust, it just peels off or falls down the coating. If you see old structures, okay, the coating peels off because you have creep underneath. So that is primarily the role which the zinc coating does. So overall, when we do the testing, as per ISO 12944, we subjected to salt spray test, we subject to water condensation test. And at the time, what will happen is, if you do a microscope analysis, you will find that the coating has absorbed moisture over a period of time, because the coating can tend to absorb it, even though it is a very robust coating over a period of long time. So at the time, the primer is definitely there to provide a duplex protection, and it will ensure that the overall system is robust, and you're getting the durability that you're looking for. 15 years, 25 years.
One more question.
Yeah, please.
Because it's very interesting.
Great.
Why what should be a proper specification, and how to define what is inside, what is outside, that there is no ambiguity. That when the people are on site going to choose an element, they go to your manual, open up, that detail, that is inside. Oh, that detail, that's partly inside. Then help avoiding all those mistakes.
We would love to do that, and we are also doing, that is why we come to forums like this, where we try and reach out, because I'll tell you, reaching consultants is probably one of the most difficult things to do, right? You ask for appointments, we don't really get it, right?
Consultant says what they want. Ask the question. The answer is not the answer question that they're asking. They ask a question. I asked, people ask questions. Sorry, I'm very
Yeah.
direct. They ask question, what is the reference how to calculate that? Is there a reference? It was about all the difficulties. The answer was, yes, there is a standard. It is reference number this. It's written in its pages this and this and this, and I can put it to you as part of the answer. This is the way I expect.
Correct.
And the same applies for this specification if you want to do that. It's going to be very simple. We are doing it about wind loading. We are specifying which part is negative, which part is positive. It can be done very based on the same principle. We can define it. It would be very much appreciated by all the structural engineers and all the owners that if something like this is there, and on site people also don't have confusion. They go to your manual and say, this manual says this is 67, but we have to use this type. And the way to calculate the distance, this is going to be 63 or this is 64. Because ambiguity is the cause of problem.
Correct. And what we have done, Reem is here, that's her area where she reaches out and provides a lot of specifications. So we can give you a very clear specification. For example, the last time we were talking to one of the consultants, they said, hey, so what is, as you said, external, what is the environment here? It's very simple. If it is external, C4, period. Don't, get, even if it is the Yas Island where you're developing, don't worry, it's only C4. We showed them the proof and say, as you rightly said, this is the answer for you, right? So we can provide you documents very clearly. Probably from what he's saying, Remus, maybe we need to make some pictures, right? That's the engineer's language. Yeah. Yeah. Yes. Correct. Correct. Yeah, I think that's and drawing is our language, right? We engineers talk using languages, that using drawings, that's our language, right? So probably we take that as a very important input here of our learning. And what we will do is we will definitely try and see if we have a nice well written document, right? What we will also try to do is pictorially say that this is external, this is semi-exposed, and what you should use for that systems. We'll do that, and we'll definitely reach out to you and reach out to others and share this. Yes, we will. Yeah. We will do that. Yeah. Mm, mm, yeah. Mm-hmm.
Food system.
Yes. Correct. I think that's a great question. I think he's talked about fendolite, which is a cementitious into fire protection system. You have boards also, which also can be used to protect it, fiber boards, calcium silicate boards, right? And intumescent. The problem is both of these systems, cementatious and boards, do not provide durability from a corrosion perspective. That is why you should not use cementatious, medium density, or even high density in a humid area. Similarly, if you box it up, okay, with calcium silicate boards, again, you'll have corrosion inside. So if you have a humid area, the only solution is to go for intumescent coating, which is the most paint-like. So again, in intumescent also, you can provide a nice zinc-rich primer. You can provide your solvent-based intumescent and a polyurethane top coat. So the system will be very robust. From a durability perspective, again, if it is a dry area, you can use fendolite or any cementitious material. But from a cost perspective, which is also important, is to understand that a cementitious material, the material is very cheap. It's cement based. Yeah, it is cheap. But the application labor cost is very high. That is why in Europe, you will not find many applications of cement, for fireproofing. It is, thing because labor cost, we still get cheap labor from the subcontinent and Africa here, right? So that is why it is still extensively used. But if you look at the boards are costly. Installation is also costly. So the boards are probably the highest cost thing. The intumescent coatings come in between. It provides corrosion protection. It looks aesthetically pleasing. So if there are architects, they will say my steel should be AESS 3, 4, AESS, right? Architecturally exposed structural steel finish I want. When they want that, the one and you also have intumescent coatings there. Fire protection is also required. the only solution is to go for an intumescent coating, which will be most paint-like, and it'll look nice, aesthetically pleasing. Yeah. Okay. Okay. Yeah. Correct. Yeah. I think Declan, that's an important question, because a lot of times what happens when people, they say I will go for cementitious, I will not go to intumescent, is primarily because of the cost of the intumescent coating, right? We were just doing some calculation, prior to this with Shapur, that hey, what is the cost? So what happens is, when a designer works on trying to save cost, they will try to reduce the amount of steel as low as possible. But sometimes, when, especially because then at the time of fire the steel will fail very quickly, so it might make sense if you slightly increase the wall thickness, the right of the steel, and then reduce the thickness of the coating. Thereby, you get a overall commercially advantage system, and Hempel can help provide that. Where we say, hey, don't use the 4 mm, go for 6 mm or 8 mm. The cost of steel is this, the coating is this, and therefore it will be cheaper. So there is a sweet spot that you can achieve where we say this is a commercially, this makes sense, and economically it works. Yeah, the section factor. Correct. Yeah. So we do that. So we can calculate, and then we can guide at every step of the way and share. Give your contact details so they can contact you directly. So you can just yeah. Okay. 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 So so that's my phone number. My email address is, oops. Where is that? When I was okay. Yeah. At apple.com. And I also have a YouTube channel. I will just, so I do post a few things where I always believe, right, the cheapest way to learn is from others' mistakes. Yeah. So so you look at some of these case histories, and we can share that, and then we will, if we learn from that, so that we don't get into these issues. And there are quite a few which, that when we go around we see that. Thank you.
Okay, well, thank you very much, everybody, for taking the time to join us tonight. And our next event, we'll start advertising for it soon. It'll be our end of year event and some COP28 events in the second week of December. So with that, we'll bring the session to a close. So thank you very much. Thank you, everyone, for joining online also.